This is Euclid Book 6, proposition number 31, and I hope Boobah 1067 is watching this because we have a little bit of a complication here. Now, it's not that bad, really. This is one of the better proofs. I'll tell you what, that's really short, nice, short, and sweet. It says in right angle triangles. Well, obviously this is a right angle triangle. The angle right here, BA to AC, this one right here is right angled. Okay? In right angle triangles, the figure on the side subtending the right angle is equal to the similar and similarly described figures on the sides containing the right angle. Let ABC be a right angle triangle having the angle BAC right. Okay? BAC, this angle right here is of course right. I say that the figure on BC, this one right here, figure on BC, is equal to the similar and similarly described figures on BA and AC. BA and AC. So the sum of these two is supposed to be equal to this. And this is the part where I don't know that I did this right at all, but we'll get into that later. Okay? Let AD be drawn perpendicular. AD is drawn perpendicular. Now, in order for this first part of the proof to work, I had to draw the following lines. This is a 4-inch line, this is a 2-inch line, this is a 3.5-inch line, and this line is 1 3/4 inches. Then, since in right angle triangle ABC, AD has been drawn from the right angle at A perpendicular to the base BC, the triangles ABD and ADC, ABD, that's triangle right here, and ADC, ADC, this triangle here and this triangle here, adjoining the perpendicular are similar both to the whole ABC and to one another. So this triangle is similar to this triangle, and these two and of course this triangle is similar to the whole thing, and this triangle here is similar to the whole thing. Okay? And this is by Euclid Book 6, proposition number 8. And since ABC is similar to ABD, ABC, ABD, the super humongous one to the smaller one. Therefore, as CB is to BA, as CB is to BA, as 4 is to 2, so is AB to BD, AB to BD. Okay? As 4 is to 2, so is 2 is to 1. So that's absolutely correct. And since 3 straight lines are proportional, as the first is to the third, so is the figure on the first to the similar and similarly described figure on the second. This is by Euclid Book 6, proposition 19, porism. This is where I get tripped up. And Boobah 1067, I hope you're hearing this. I'm going to read this real slow here. And since 3 straight lines are proportional, okay, as the first is to the third, so is the figure on the first to the similar and similarly described figure on the second. Therefore, as CB is to BD, as CB is to BD, okay, as this great big line is to the smaller line, so is the figure on CB to the similar and similarly described figure on BA. So as CB is to BA. Okay, so that in addition, as BC is to BD, as BC is to BD, as 4 is to 1, okay, alright, I'm sorry, let me try it again. So that in addition, as BC is to BD and DC, well, BC is to BD and DC combined. So in other words, you have as 4 is to 4, because BD and BC is 3 plus 1, and it's going to be 4. So as 4 is to 4, so is the figure on BC to the similar and similarly described figures on BA and AC. So as this is to this and this. But BC is equal to BD and DC. So the area in BC is supposed to be equal to BD and DC. Well, here's... Oh, okay. Sorry. Scratch that. But BC is equal to BD and DC. So the line BC is the same length as BD plus DC. So 4 is equal to 3 plus 1, obviously. Therefore, the figure on BC is also equal to the similar and similarly described figures on BA and AC. And that's basically the proof. So, if you guys know what's going on here, that'd be great. Leave me a comment down below. I hope I got this correct. If I didn't, let me know. I will tell you more in a future video, so stay tuned.